Hey guys, today we're going to investigate patterns of association in bivariate data. So what we need to do today is to know that straight lines are widely used to model relationships between two quantitative variables. So for this scatter plot that suggests a linear association, we're going to learn how to informally fit the straight line and how to assess the model of fit by judging the closeness of the data points to the line. So we're going to be examining the fit of everything, just like we did yesterday, but with a little bit more specifics. So let's get started. Remember, as we're looking at a scatter plot, we're looking at a graph where the values of two variables are put on two axes, with the independent variable on the x-axis, the dependent variable on the y-axis, and the pattern of the resulting points will show us whether there's any type of correlation present. A line of best fit is a line that you draw on the graph showing the general direction that the points seem to be moving in. Remember when we found the positive trend, the negative trend, or no trend? Well, the line of best fit is either going to be a positive line of best fit or a negative line of best fit. So let's get started. A scatter plot is used to investigate whether there's a relationship between two data sets. In this data set, we need to plot the points from the table onto the graph. When you do that, you look for a clustering, and you look to see if there's a line that you can represent the correlation between the two sets of data. Here you can see where the line of best fit is drawn through a majority of the points. Notice that there's 1 point above the line and 1 point below the line. So most of the lines actually correlate or fit, showing a positive trend. Let's take a look at this a little closer. In this table that I'm showing you now, you see the height and the age of 5 girls. So we're going to plot this data to see if there's a relationship between their age in years and their height in centimeters. The first thing we do is we draw our coordinate axes. And we need to find if a girl's height depends on the girl's age. So that makes age the independent variable, which goes on the bottom, and height the dependent variable that goes on the vertical. So now we have to choose our scale. Since our age goes from 2 to 10, we're going to use a scale of 2. And on the y-axis, since we go from 85 to 140, we're going to use a broken line to show that we didn't start right at 0 and we're skipping some numbers. And we're going to start at 80 and go above because we don't need the ones that are below it. You're going to see that broken line a lot. Now we need to go and we need to plot our ordered pairs. For a girl who's 2 and 85 centimeters tall, you graph the X and the Y ordered pair. Continue for the 4-year-old at 100 centimeters, then 6 at 115, 8 at 125, and last, the 10 at 140 centimeters. Now we have a scatter plot, and we need to look to see if there's any type of line of best fit. Remember, the line of best fit can be a positive correlation, a negative correlation, or if we can't fit a line to the data points, we just say there's no correlation. So now we're looking at the same age and height of girls, and we want to predict, is there any type of relationship? And if so, what kind of relationship is it? Looking at our scatter plot, we can fit a line that goes through a majority of the points. That trend line is called the line of best fit. So as age increases, height also increases. This is a positive trend. And the data points are located very close to our line of best fit, so we have what's called a strong positive correlation. Now, because it shows a strong positive correlation, the line of best fit can be used to predict values that were not part of the original data set. So we can make other predictions for things that haven't even occurred yet. Since age is plotted on the x-axis, to predict the height of a 5-year-old girl, you would take the 5 and follow it up to your line of best fit and over to the y-axis, and you can see that when a girl is 5, the likely height that she'll have is 107 centimeters. Now remember that this is just a prediction. Every 5-year-old girl won't be the same height. This is just what our trend shows. If you wanted to make a prediction for data that's not even on the line yet, you would extend your line of best fit with a straight edge, and you would go to that value. For example, an 11-year-old girl is outside our plot of values. So if we follow it up to our trend line and over to the y-axis, we can see that an 11-year-old girl is most likely to be 152 centimeters tall. But remember, this is only an estimate because not every 11-year-old girl is going to be 152 centimeters. Now let's take that information and let's move on to the examples that we need to work. If you're given a scatter plot and you're asked to produce a line of best fit, you would just look and say, okay, where's the trend? You can see here that I'm drawing a line of best fit. Oh, I'm drawing on the graph. Sorry, guys. Well, let's try that again. The line of best fit is not the squiggly line that I just drew. You can tell I'm in my car driving today. Sorry. The line of best fit will be a straight line. We'll do it this way. Will be a straight line that passes through a majority of the points. And I don't know why it won't give me the line, so let's try it again. You can see that it should be the straight line that passes through those points. And when you look at the line of best fit, how many dots do you see above the line? 1. And how many dots are below the line? 1. Let's move on. In your notes, you have collaborative practice problems. Find your problems, and I want to work through these together. You can pause and try these on your own and come back, or you can look at example 1 and then pause after we've done it together. If you get stuck, come back because we're going to work through all the collaborative practice on this video. In problem number 1, variable X is the number of students trained on new projects, and variable Y is the number of calls to the other institute. You suspect that more training reduces the number of calls. Does this follow positive correlation or negative correlation? When you are answering questions like this, you should always write down on your paper what the variables represent. X represents the number of students. And Y represents the number of calls. Now that you've written down what they represent, sorry about the scribble, you can make some predictions about the data. Look at that last sentence. You suspect that more training reduces the number of calls. So more training, in other words, if you increase the number of students, you're going to decrease the number of calls. When one value increases and the other value decreases, what type of correlation is this? Positive or negative? It's negative. And so you would do that. Now you can pause the video and continue the others on your own, but if you get stuck, come back and I'll explain them to you. So, here's number 2 in case you got stuck. It says the table lists the population of a town from the year 1970 to 2003, sketch a scatter plot of the data. So the first thing I'm going to do is make my scatter plot a little bigger because on this screen it's going to be hard for you to see. And so to do that, I need to get rid of the ink that's in the way. So let me clean that up and let's come back and look at our data. We need to plot each of the ordered pairs. So I'm going to take the ordered pair for 1970 and 50 and I'm going to plot it first. Now remember, I'm traveling, so my lines may not go exactly where they're supposed to go. My first dot goes here. I'm going to go back and I'm going to repeat this process for each of the ordered pairs. So now let's do 1980 and 35. 1990 and 45. 2030. 2001, 60. 2002, 65. And 2003, 70. Do we see a trend in the data? Yes. It looks like most of the points will fit on a line. And my line's not exactly straight. You would want to use a straight edge. But it looks like we have a positive trend. So you can see that I've informally drawn the line of best fit for number 3, and the type of correlation that the graph shows is positive. Now, it didn't ask me, but one of the things I always do is I always look to see how many points are above and how many points are below my line of best fit. It looks like I have 1 above and 2 below. On yours, it may be a little different because notice, I'm moving and so my line's a little squiggly. Now you can pause the video and go on to the next. On number 5, when they ask you to calculate the slope of the line through the 2 points, remember you have to use your slope formula. So the slope formula is m equals y2 minus y1 over x2 minus x1. Label your points just like we do in class, and then perform the slope. When you do this, 2003 minus 2001 gives you 2. And 60 minus 25 is 35. And so the slope is 2 over 35. The equation of the line has to be written in the form y, that looks like an x, but it's y equals mx plus b. We're given the y-intercept of 2000, so our equation should be y equals 2 over 35x plus 2000. It says to predict the population based on the year 2003, but there's no prediction to use. We can go back and look dead at our point, and we can find that the year is 60. Now that you've done that, look at the graph. It says use the graph shown for questions 8 through 10. What type of correlation does this graph show? Remember, you're looking for a trend, so look for clustering. It looks like, if I can draw it, it looks like we have a line of best fit that goes through the points like this. What type of correlation does that graph show? It shows a positive correlation. Can we predict the distance traveled at time equal 4? We absolutely can. Look at 4 for your time, not 3 that I just circled, sorry guys. Follow it up to the graph, to the line of best fit, and over, and you can see that it would be somewhere around 48. And if you look at the distance traveled at time equal 2, and you follow that up to the line, let me get rid of this other marking where I'm scribbling so much. But if you go to 2 and follow it up to your line of best fit, and then go over to the y-axis, it looks like it's around 25. Now, these are estimates, so your numbers may be just a little bit off, and that's okay. That completes the video. You're ready to do your independent practice now. I want you to show your best work and do your very best. We'll go over the answers to these tomorrow. Have a good day, and remember, do your best.